Hi, my name is Hernan Julio, and with the producer Francisco Rodriguez, we will be your guides in this new virtual experience at the European Southern Observatory, or ESO. I want to tell you that this visit are a new experience for everyone, and your help to improve this tour is very welcome. For this reason, at the end of the tour, we will give you a survey to receive your comments. In the next hours, we will travel to the region of Coquimbo in the northern Chile. We will virtually visit ESO Silla Observatory at 2,400 meters above the sea level. But today we have a very special guest with us, Ivo Saviani, ESO astronomer and site manager of La Silla Observatory. Ivo will answer your question related to astronomy and La Silla. Ivo, thank you very much for being with us today.
Thanks, Hernan, and thanks, Francisco, for inviting me. Welcome to everybody to this virtual tour, also in the name of the observatory itself. I'm here ready to answer your questions, so I hope you will enjoy it.
Thank you, Ivo. Remember that at the end of the tour, Ivo will be with us and we will have some time to answer all your questions. We invite you to start thinking about your questions. I imagine you maybe have already many of them. From now on, you can write your question or comments in a section specially dedicated to this. You can ask your question, you can indicate your name and city, and we will read them through the tour. Francisco Rodriguez will be waiting for your questions. Now, let's start the tour. As I already mentioned, we are in South America, in Chile. Let me show you at your left, you have the map, and let me make a close-up to South America. Here we are. This long and skinny country is Chile. And La Silla Observatory is it's in the northern part of the country. Let me show you here. You can see Santiago de Chile, which is the capital of the country. And one second, please. There we go. And Santiago de Chile is about 600 kilometers south from La Silla, which is this dot right here. I will recommend, if you want to come to Chile to visit us, you can fly to Santiago de Chile and then go to La Serena, flying or driving. It's about 5-6 hour driving to La Serena. And from La Serena, there's a 2-hour driving to La Silla Observatory. I remember you that we are open every Saturday at 10 o'clock and 2 p.m. Of course, and that's the reason because we are giving you this virtual tour. We are closing this right moment, but we hope to open as soon as possible. And we will let you know through our social media and our webpage. Well, we are in the Andes Mountains. Let me give you a little panorama of where La Silla Observatory is. It's right in the heart of the Atacama Desert, in the Andes Mountain, the Cordillera de los Andes. And you can see that we are in the desert, and also right there we have the La Silla facilities. Well, the first thing that we can notice in this image is La Silla has so looks like a little bit, the mountain looks like a saddle, as you see here. Okay, so that's why we call La Silla Observatory. And here the main telescope that we can see from far away is the one that is in the center here, inside of this light blue dot, and that's the 3.6 telescopes. It's a giant telescope, a classical telescope, and today a real extrasolar planet hunter. We will talk about that a little later. And of course, to the right here, you can see the next and the new technology telescope, the NTT, also a very important telescope at La Silla. Right now we are in the middle of the road to La Silla Observatory, but we want to go to the observatory, and for that we have a video for you, so we can make a fly over La Silla. I think there we go. And
Yes.
as you can appreciate, thank you, Francisco, for this. And here we are flying over La Silla. As you see, we have about 10 10 domes, 10 telescopes that are working right now, and ESO is in charge of the 2 of them. The NTT, we're getting close to it. Well, in the center, right here, you can see in the center of the movie, of the video, you can see the 2.2 telescope, this silver dome here. The next to the left, we're passing by now, is the Smith telescope, and of course, the next one, the sort of a square telescope, is the NTT, the New Technology Telescopes. Okay, and this flying over the observatory will take us finally to the 3.6. Little to the right. Yes.
Well, hello to everyone. Thanks for watching us. We have a tremendous audience in this moment from everywhere. I just want to briefly mention from the UK, from Brazil, from New Zealand, from the US, I think from Denmark also. So please send us your question. Ivo is waiting for you at the end of the tour. We will have a special moment for him to answer all your questions. And please just let us know what you would like to see in the following moments. Hernan, back to you.
Yes, well, here we're getting close to the 3.6 meter telescope. It's a classical telescope, was inaugurated in 1977, and the antenna that you see there is the radio telescope. Well, let's go back to the tour, and we will be in the mountain. Let's take a look from the ground now. Here we are in this point. Let me give you a little panorama what you see from La Silla. Now we look into the west. This is almost sunset, but this point, this viewpoint here, what I'm showing you right now, was very important last year, because here in La Silla we have we were one of the observatory that was under the total solar eclipse last July 2nd, 2019. La Silla was right in the spot where totality we were able to see the totality. The sun was a little up, only 14 degrees, about 14 degrees above the horizon. So we have a really special point to see the eclipse. As you can see here from the ground now, you see an image of the whole observatory. And 2 things that we already noticed in the video is that we have 2 type of domes here: the classical dome to the right with the 3.6 meter telescope, and of course the NTT, the New Technology Telescope. Both of them we're going to visit today. So let's go right away inside of the 3.6 meter telescope. As you can see, it's a huge telescope, a really giant telescope. We can notice, first of all, let me give you a view of the inside of the dome. It's really a huge dome, and let's show you a little bit the telescope. Here we are. The telescope, as you can see, is this has 2 important parts. First, all the light blue part is the telescope itself, and then you have this mount, the blue part. The mount is a quaternion mount, and this is a classical mount. And as you can see, it's a very big telescope. At the left, you can see here in the ground. Let me give you this close-up. You can see there is an engineer here, a person who's working right there, and you can take a look at the size of the telescope. Okay, from the bottom, where the man is, to the top of the dome, you have 25 meters. Just to give you an idea of how big is the telescope. Also, the telescope has two main parts. The heart of the telescope, of course, is the mirror. The mirror is right here in the center. Let me show it to you. Here's the mirror. We cannot see it, but it's inside of this round light blue part. It's right there. And the second important part of the telescope is the secondary mirror, which is inside of this black tube. For that, let me show you the picture. To your right, you have a picture from above, and you can see, of course, the blue part, which is the mount, who moves the telescope in the night to following the stars. And then you can see the secondary mirror here. And this part, this black part, which is a tap, which is closed because it's this image was taken in the day, but in the night will be open. And how the telescope get the light from the star? Well, in the night we open the dome. Today, in this picture, we have the dome open. So the light will be open like as you see it right now, and the light will go inside of the telescope straight to the main mirror. Okay, the main mirror is a round mirror. It's have a hole in the center and have a little cube. It's a 3.6 meter in diameter, and it has a surface of aluminum. The aluminum surface will reflect the light of the star and will go up to the secondary mirror. From the secondary mirror, the light will go straight back in a beam of light to the center of the mirror, will go through the hole of the mirror, and will get in this cage. In this cage right now, we have the fiber optics of HARPS. The HARP is the instrument that we are using now in the 3.6 mirror telescope, and HARP is a very special instrument. Who the HARP gets the light from the star, but it's very special because it's detecting planets around other stars. Okay, what we call extrasolar planets. Is the only instrument that we have right now in the 3.6, and has become very famous because has discovered different and very important planets around other stars. So that's so far what I can show you inside of the telescope, but I would love if we have some questions, and maybe Ivo can help us with those questions and comments. Thank you very much for being with us today.
Yes, actually, we have a lot of questions. And the first one, I would like to ask the help of Ivo to answer this. There's a lot of people curious about the other telescopes or domes that we have at La Silla, because we mentioned that we only operate 2 of them. So the question is, are they the rest of the telescope empty, or what are they doing there?
Yeah, okay, welcome everybody again. Yes, we have many domes indeed, the observatory. Currently, yes, indeed, we operate only the 2 main ones, the 3.6 that you see here, and the NDT you will see later. But a number of smaller projects, which we call hosted projects. These are projects not directly operated by ESO, but by countries or universities or institutions in countries, even consortia. We have, at the moment, active are 10 of them, but we have 2 more in construction, so in the near future will be 12. And there's another one, the ESO 1.52 meter telescope, that is also going to be refurbished for another project. So we will have 13 in the future. So in other words, most of the domes are not empty, are used by other projects.
Great, thank you. We have another question. Why so special that 3.6? Is asking someone from Croatia, I think. Ivo, can you answer why HARPS is so special?
HARPS is special because, well, it's a spectrograph, so it's an instrument that splits the light into its different colors, and it's the specialty is that it's extremely precise. So it can, well, as you know, to detect a planet, you basically look at the star and see how the mass of the planet will reflect onto the motion of the star. And to detect this motion, we look at the spectral lines in the spectrum of the star. And this spectrograph is able to detect, to measure this displacement of lines with an extremely high precision. It is the most accurate accurate spectrograph of this class in the world. To give you an idea, if you were on the moon with a light, with a torch, it could detect your movement if you would walk on the moon. So that's the kind of precision.
Great, thanks. We have another question related to if from La Silla has any telescope which can detect near space or Earth objects, objects that can potentially collide with the Earth.
We have a dedicated station. There is a project by NASA which is called well, it basically looks every night from bolids or meteorites or traces of objects that fall from the sky, from outside the Earth, and then it determines its origins. And so it can, at some point, if you correlate all these events, you can find the debris of comets or other objects that could potentially be harmful to the Earth. So we have a little project like that, indeed.
Great. Hernan, please, let's continue with the tour. Thank you, Ivo. Ivo will be during the rest of the tour. So please send us your questions. We will be answering during the tour. And at the end of the tour, we will have a special moment with Ivo to answer all of your questions. So please.
Well, thank you very much, Ivo. Thank you, everyone who's watching from all over the world. We will continue with this tour. We'll go outside again and to take a look to this beautiful sunset. As we told you before, we have also the NTT, the New Technology Telescope. First thing that we can notice between these two telescopes is the way they are built, the architecture of the telescope. We have the round classical dome to the right here in the 3.6 telescope with the one that we just visit. And we have, of course, this more square telescope. Let's go inside to the NTT to have a better look of the telescope. Here we are. As you can see, the first thing that we can notice, first of all, is that this building. The building is, as I told you, a little square, and also the building itself rotates in 360 degrees. So during the night, the whole building will rotate in 360 degrees. And the telescopes looks like a little smaller than the classical 3.6 meter telescope, but works almost basically almost the same. It has also two main pieces: the main mirror right here, which is in this case 3.58 centimeter in diameter, almost the same diameter than the 3.6 meter telescope, and also it's a round telescope with a hole in the center. But in this case, it's very thin, only 24 centimeter thick. It has aluminum surface. It's a very thin amount of aluminum. It's like thinner than a human hair. And that aluminum is the one who reflects the light. So the light will go inside in the night, will go straight to the main mirror. From the main mirror will be reflected to the secondary mirror, which is right up here. And then the light will go back again in a dim of light reflected to the third mirror. In this case, yes, we have a third mirror in the center, which is in 45 degrees. And we can send from there, we can reflect the light to the right or to the left. Why is that? Because the instrument in this case are by the side of the telescope. To the left or to the right. Over there we have the instrument who capture the light and send the light by fiber optic to the control room where the astronomer works. Also, and very important, is that one of the reasons because this telescope is called the New Technology Telescope is because the mirror has active optic. What is active optic? Well, the active optic is inside of this cell here, the main mirror cell, M1 cell, which has actuator. Maybe let me get closer to it here. Underneath the mirror, we have actuators, or it's like piston that push up the mirror in order to keep always the surface perfect. That's the active optic, and we have this mirror because it's so thin that the mirror, when we work at night, when the astronomer is using the telescope, the surface of the mirror could change nanomillimeters. No, you cannot see it with your own eyes, but the computer will detect the problem, will correct it on real time. That means that while the astronomer is observing the stars and galaxies. Let's now take a little look to the secondary mirror. You can see right here, and also you can appreciate the roof of the telescope. The telescope is also the other difference that we don't have the regular window or opening of the telescope, but what we do is to open the whole building, the roof of the building. So in that way, the light will be able to get inside, to go to the main mirror, secondary mirror, third mirror, and then to the instrument. And from the instrument, the information, the data, will go to the control room. Okay, and maybe I'm sure we have some more questions, and maybe to explain a little bit where the astronomer works. Francisco?
Yes, we will invite again Ivo to explain a little bit what is happening in this control. This is the control room of La Silla. Ivo, can you explain us a little bit where is the La Silla control room and what is happening in this video?
Yes, yeah, the control room that you see here is a room which is in a building that is a couple of kilometers away from all the telescopes. From this room, we operate 3 telescopes. You see 2 here, 2 sides. On the right, there is the 3.6 meter consoles, and on the left, the NTT. And further back, there will be also the 2.2 meter. And so from there, so usually, you see many people here, but usually the main ones are the telescope operator, who is a staff of ESO that will help the astronomers point to their object. In the case of NTT, for example, adjust the mirror shape, acquire the target into the field of view. And on the other side, you have the visiting astronomers, which come from everywhere in the world, and which will design the program for the night, so the list of objects to be observed, and they will interact with the telescope operator to perform their program.
Great. How astronomers can this is a question. How astronomers can observe with ESO telescopes? Just they knock our doors, or they just simply send some request to ESO? How is the process, please? If you can explain this.
Sure. Yeah. Basically, 2 times per year we issue what we call a call for proposal. So all the scientific community is invited to send their proposals to us. There is a web interface to do that, and then there is a committee selected among community astronomers that will rank the proposals, and the top ones will make it to the actual observations, and they will be scheduled. And then, if you receive time, you will be invited to come and observe with our instruments.
Great. Let's go back to the tour, Hernan, because we have more surprises to come.
All right, so we will go outside again, but now at night. I remember you that in normal times we have tours every Saturday at 10 o'clock in the morning and 2 p.m. every Saturday, but our visitor cannot stay at night. So thanks to technology and to this virtual tour, we're going to be able to show you this gorgeous sky over La Silla. And for those that know the sky, let me show you first one of this constellation that is about to set. Here we have what we call the Orion constellation, the Hunter. Okay, for those that do not know too much the sky, let me help you with your imagination. First, we have these 3 stars here. We call it in Latin America, we call them the 3 Marys, or las Tres Marías. Okay, but this is the Orion belt. Okay, from the belt you can go and have one leg to here to the left, and then another leg to the left, and to the right we will have the shoulder, and then we have the another shoulders. So you can see the body of the hunter. I know you have to have a lot of imagination for this. So the Greeks did this constellation, imagine this constellation in the sky. But there is a very special point here, because any hunter, any warrior needs a sword, and here we have it. Okay, and this point, this red point there, this picture is a very nice picture, so we'll be able to see what we call the Orion Nebula. Here is where thousands of stars are born in this right moment. Also, let me show you from far away. You will see, for those that are looking to the sky and know the sky in the northern hemisphere, you will see that this constellation, that Orion, is upside down. The head of the Orion is around here, another arm will be here, and the shield of the Orion, of the hunter, will be here. So we are looking at upside down because we are in the southern hemispheres, of course. And any hunter needs a dog, a very nice a dog who help us to hunt around the places. And here we have what we call the Canis Majoris, el can mayor, or the big dog. Here is Sirius, the brightest star in the night, and it's the eye of the dog. This is the back part. Let me help you again with your imagination. This one leg, then we have another leg, and the tails. Okay, so the big dog, or the Canis Majoris, is always with his good friend, the hunter. But these two constellations are very close to the Milky Way, this river of a star that you're looking at here. Now we will go to the southern part of the sky. Okay, let me show you here. We will be looking to the south. This part of the sky that we are looking right now is, you can see it only from the southern hemispheres. The first two main objects that you will see in the sky, in the southern sky, you will see these two clouds here to your right. Okay, these are the Magallanes clouds. The name is because Magallanes, Hernando de Magallanes, who was the first to go around the world navigating, when he did cross the Ecuador, he saw this new sky over the sky, this new constellation, this new object, and he saw these clouds, and he thought they were clouds, atmospheric clouds, I mean. Today, we know that they are galaxies. There are two satellite galaxies which are going around our own galaxies. Okay, but he found something else. He found that he could use these two galaxies in order to navigate in the southern seas. So how he did that? Well, he make it a triangle. Okay, if you go from the main Magallanes cloud, the large Magallanes clouds, you make a triangle with the second or the small Magallanes cloud. If you make this triangle here, you will find in this spot the southern celestial pole. What is the southern celestial pole? Well, it's the point where all the stars at night rotate. From the southern hemisphere, you will see them rotate clockwise this way. Okay, actually, if you are at La Silla, you will never see these stars setting at night because they are circumpolar. That means they never set if you are in the southern hemisphere. But let me give you another tip, just in case you come to Chile and you get lost. You also can use this another constellation here. Maybe you already recognize it. We call it the Southern Cross. Here we go. This is the Southern Cross. And you can use also the Southern Cross to find the same point, the same center, the celestial pole, the southern celestial pole. And what you have to do with the Southern Cross is to extend the main stick of the cross. this stick is always pointing to the south, so you go 1, 2, 3.5, and you will be right in the same spot, in the same point, with the triangle that you virtually make in the sky with the Magallanes cloud. That way, you will never get lost. You just from that point go down to the horizon, and you will have the southern part, so you can follow that southern point if you are in the desert or anywhere in the southern hemisphere. So remember, Southern Cross and the Magallanes Clouds. But our pre-Columbian people, the pre-Columbian civilization in Latin America, they were very good astronomers too, and they also have this sky and without no light contamination, light pollution, and they could see this. This is the Milky Way, and they could see very well this is dark spot in the sky. This dark spot in the sky are a cloud, are gas and dust cloud that doesn't let the light that which is behind them to go through. That's why you can see this very nice dark spot. And they saw in this dark spot constellation. Actually, here we have a very beautiful constellation, which is called Llama constellation. You can see the head of the llama right here, the neck, and then we have the body, legs. Okay, I'm sure you already can see the Llama constellation. And of course, Llama has an eye. That eye is the Alpha Centauris right there, is the eye of the Llama. And we have Alpha and Beta Centauris. Alpha, by the way, is one of the closest stars from our own solar system. Also here, what we, the Western, call the Coolsack, they used to call it the Frog constellation. And they have many other constellations. These animals, for them, the Milky Way used to be a river where all these animals went to drink water every day. So, well, as you see, this sky is a really gorgeous sky. It's a beautiful sky, but we have to continue. The time is short, and we also have many questions, I'm sure, from our visitor today. Francisco, please.
Yes, well, thank you so much for all your questions. I have at least 5 for you. First, I would like to say that we will have another tour following this one in one more hour to Paranal in Spanish, because there are many people who is watching us right now from this side of the world, and they're asking us, is there any Spanish available? Yes, we have one. So just stay tuned in the following hours, minutes. And let's continue with the questions. Ivo, the first question is for you. It's let me find the name of the person who did this question. Is okay. Are those is from Period? Are those telescopes cooled by some sort of liquid gas?
Well, the telescopes themselves, the enclosures are air conditioned, most of them, because we need to keep the inside of the domes at a stable temperature, because otherwise, although the main mirrors are made of a low expansion glass, so they don't change much with temperature, the changes are enough to compromise a bit the image quality, so we need to keep the temperature stable. But if you're talking about instruments, then the detectors and sometimes the whole instrument is cooled down by either liquid nitrogen or liquid helium in case of infrared instruments, like the one we have at the NTT, which is called SOFI.
Great. Another question: which countries can send proposals for observations?
So ESO is funded by 16 European countries. So preference is given to proposals from those countries, but we open our calls to scientific community in the whole world. So you are free to submit your proposal, and if there is scientific merit and you don't have at your disposal any instrument that can do the job that we can do, then you are welcome to send your proposals to us.
Great. Ivo, can you explain the difference between a equatorial mount and a regular or azimuthal mount in a telescope? Maybe Hernan can help us with the 360 image to explain a little bit more.
Yes. Let's go inside of a 3.6 again, so we can see the equatorial mount to explain this.
Yeah. Yes, so this is a classical telescope, the 3.6 meter, and to point to any star in the sky, you need to move it along two axes. One is the polar axis, which is it's not visible here, but it's defined by this horseshoe here. So orthogonal to this horseshoe, you have the polar axis, and where you have this big circle, which is the delta motors, you have the declination axis. So the telescope can move both in what we call right ascension and declination. So there are these two axes. Yeah, so this is the classical mount, and at azimuth would be instead the entity, which I think we can see soon.
Let's go to the entity.
Here you see it's different. So this in this case the first axis is the azimuth, so it's a vertical axis. So you don't see it here because the telescope and the buildings are rotating in sync. But during the night you would see that this telescope rotates about its vertical axis. And then you have the elevation, which is orthogonal to this, so it's horizontal in this case. And so the telescope can move up and down along this axis. Now the other big difference is that in this case, when you have an alt-azimuth telescope, the light, as Anand said, goes to the left or right where the two instruments are. But the problem here is it's a bit long to explain, so I will not go into details. But there is something called field rotation. So if you attach an instrument to the sides of this telescope, which we call Nasmyth foci, then you need to derotate. So to compensate with the derotator the movement of the sky around the central point of the optical axis. So it's a bit more complicated in a sense, but it's easier in another sense because it's lighter, it's more compact. You can see these two telescopes have the same mirror, but they are much different in dimensions, which means also in cost and mass budget. So I think those are the main differences.
Ivo, it seems like we have a sound problem with your. So maybe you can not use earbuds or just to use the sound of your computer, the mic of your computer. In the meantime, I would like to say the people that we have as Hernán says also, we have a survey to see what is good of the tour or is not so good of the tour. Please, you will find in the comment section of YouTube or ESO Astronomy this form. Please fill it. It's only 5 questions, is less than a minute, and it's going to help us a lot to get better, to do a better service for you, a better tour for you in the following days, weeks. And let's continue with the questions. We have a question related to astronomy. So, is the Milky Way visible the whole year in the southern hemisphere, Ivo?
Yes, as Hernán pointed out, if you look towards south, you will see that the Milky Way crosses the sky near the southern pole. I hope you can hear me right at this point.
Yeah, we have a little problem, yes, with your sound. Maybe you just pull off.
Yeah, I just changed the microphone. Let's see, maybe remove.
Yeah,
closer to the laptop and see if things get better. Yeah, so well, I'll speak louder. So since the Milky Way crosses near the southern pole, then this means that also part of it will be visible the whole year, but lower or higher in the sky depending on the season. The best season would be the southern winter, when the Milky Way is half on the sky.
Great. Do you have? We have a personal question here. Why did you study astronomy? And what kind of science
That's a
do
very
you do?
interesting one. Yeah. Now, for me, the main motivation was curiosity, just to discover things, understand things. And if you look, the universe is the biggest mysteries of all. And so that is, if you start from there, all the rest comes as a corollary, you might say. So understanding the universe was the main motivation. And also, as you can see, the fascination with the sky. You look at it and you want to know what it is, how it works.
Ivo, this is also a personal question. Is alien exist, or have you ever seen something at La Silla? This is a question that always we receive during the tours. What do you think?
No, personally, I don't think so. We never seen anything special. If you talk about life, it's likely that it will happen somewhere else in the universe. Maybe not as advanced as ours, maybe at a more simple level. But aliens visiting us, no, I don't believe so.
Great. So this is for Nana. So how we can visit La Silla, and can we go by night?
Well, you can visit La Silla in normal times. We're closed right now every Saturday at 10 o'clock in the morning to 1 p.m. and also from 2 p.m. to 5 p.m. So at night it's not possible. That's why we're doing this tour and enjoying this sky, because in the night we won't be able to hold you at night. But if you come to La Silla in the night, you can go anywhere close to La Silla with all your light down, of course, and you will be able to enjoy all this sky too. So the Atacama Desert is a big desert, long desert, where you can stay at night and enjoy this beautiful sky too.
Ivo, we have another question for you. It's related to the nighttime and the daytime. Can we use the telescope only during the nighttime? Can we use it during the daytime too?
Well, mostly we use them at night, also because since these are optical telescopes, as you can see, stars are visible at night and not during the day. But there are a few exceptions. It's not now used; it's decommissioned. But we've seen at the beginning a dish, which is maybe Hernan can point to it again, and that would work at 24/7 because that was working in sub-millimeter waves or wavelengths when where the sky doesn't change compared to night or day. And also we had an instrument at some point at the 3.6 which was called TIMI, which was a mid-infrared instrument, camera and spectrograph. And also in the infrared or mid-infrared, so 10 microns, 20 microns, also there is no big difference between day and night. And so you could observe during the day with lots of precautions, of course, because if you point to the sun, you can imagine what happens to your instruments. But for example, we used it when there was the Deep Impact mission. You remember probably that there was a projectile launch into a comet a few years ago, and then the 3.6 with this instrument was one of the first to observe it, and this was at 1 in the afternoon.
Great. And then can we go, in the meantime, we have time for 2 more questions. So please send us as soon as possible your questions, and Ivo will be here for answer them. In the meantime, now can we go to the hotel of La Silla?
Of course, we will invite everyone to go to have a coffee at La Silla. Here we are in the hotel. And so we can relax and maybe answer some more questions. Ivo could answer some more questions to us.
Yes, exactly. We just received one from Co. So, do meteor showers affect the telescope viewing, Ivo?
Not that much, because the field of view of every instrument is only a few arc minutes at most. So you must be really unlucky if light passes through that field of view. But it happens. It happens maybe a few times per year. It's not a big problem. If you notice that, then you will observe again. You take another image, which will remove this this stripe. So in general, I wouldn't say that it's a big problem.
And the last questions that we can answer. Sorry for those who are sending us right now questions, but time is very cruel in these situations. So it's a question. It's an open question. Is what kind of recommendations do you have if I want to study astronomy?
Well, you have to have this curiosity that I said before, not taking anything for granted, wanting to find answers for yourself. And okay, I guess you have to go to university, right? So there are astronomy departments around the world where you can study astronomy. Maybe some people perceive that it's a light kind of study, but it's actually lots of physics and mathematics. So you have to be prepared to study quite intensively this subject.
Thank you so much, Ivo. I'm sorry for time we cannot answer more questions, and I would like to invite to the people who is watching us to the next tour that we have in an hour or so. To Paranal is in Spanish. We will have more tours to La Silla in English and more tours to Paranal in English too. So if you're watching us, just stay tuned in our social networks. I would like to say thank you so much, Ivo, for your time.
Thanks to you, and I hope to see some of you in La Silla one day.
Hernan, back to you.
Okay, thank you very much again, Ivo. Thank you everyone for watching. And remember that we have our webpage where you can see the same, you can use the same tool, which is the virtual tour, and ESO.org. ORG, and over there in that in our webpage we have thousands and tons of videos and pictures, image that you can download in different formats. So we invite you to visit us in our webpage, ESO.org. Thank you very much, and we will see you again in next tours. Thank you, and thank you to you too, Francisco.
Thanks. We will let you with a little taste of our next tour. And thanks once again, Ivo, for your time. And Hernan.
Goodbye.
Bye-bye.